My name is Lincoln Zotarelli. I'm an associate professor at the Horticultural Sciences Department at the University of Florida. This presentation focuses on nitrogen fertilizer best management practices for fresh market and processing cabbage head production in Florida, including management strategies that comply with statewide BMP guidelines to optimize economic yield while minimizing nitrogen losses to the environment. The guidelines presented here are supported by field-based research conducted by IFAS and lay the foundation for precision agriculture efforts for fresh cabbage production in Florida. Cabbage is planted in about 9,000 acres with a value of production of almost $50 million. Cabbage is produced in several counties across the state and is a cool season crop. In fact, weather during the growing season is a major driver for yield. Thus, differences in yield are expected between years and even planting dates within the same year. For example, first planting dates around October are characterized by fast initial plant growth, short season, and higher yield. Planting dates during November coincide with lower air temperature and reduced solar radiation, resulting in longer season between planting date and harvest, and relatively lower yield potential. The majority of cabbage fields rely on seepage irrigation due to the predominance of spodosols with a shallow water table. Here's an example of a cabbage field with irrigation furrows spaced every 60 feet, and relying on a water retention structure to manage the water table level. There are also cabbage production areas with predominance of well-drained soil profiles where sprinkler irrigation or drip can be used. For both soil types, cabbage can be produced either on bare ground or plastic mulch with drip irrigation. The commercial production of cabbage under seepage generally uses bare ground hills spaced 40 inches apart and in-row spacing between plants of 8 inches, which results in approximately 9,600 plants per acre. On well-drained soils, row spacing is generally reduced to 36 inches with 8 inches in-row spacing, giving approximately 21,780 plants to the acre. In plastic culture system, cabbage is generally grown 4 foot wide raised beds spaced 6.67 center to center with plastic mulch and 2 drip tapes. The increasing surface area covered by the plastic mulch allows for different plant spacing and arrangements, leading to an increase in cabbage plant population per area. The response of cabbage nitrogen fertilizer were evaluated for 2 consecutive years. The plant population in this study was 19,600 plants to the acre, and all fertilizer treatments received 45 pounds of nitrogen at pre-plant using an NPK blend, and followed by another 3 subsequent applications at 42, 60, and 78 pounds per acre, totaling 170, 225, and 280 pounds per acre of nitrogen. Note that this is equivalent to 0.009, 0.011, and 0.014 pounds of nitrogen per plant, respectively. The application occurred at 14, 28, and 40 days after transplant. The 2 contrasting patterns of rainfall occur. In 2016, the cumulative rainfall from transplant to harvest was 10.5 inches, with 2 major events of 2.3 and 2.4 inches early and late season. The 2017 season was much drier with only 2.1 inches of rainfall. So the cabbage yield response to fertilizer was directly related to the precipitation within each season. In 16, increase of any rates did not increase total or marketable cabbage yield as seen on table 3. Cows were about 14 to 16%. The lack of yield response to nitrogen fertilizer indicates that Nitrogen was not a limiting factor for cabbage in that year. On the contrary, the main reason for reduced yield may be attributed to reduced solar radiation available due to the overcast, dry skies, and low air temperatures during crop maturation. The growing conditions were more favorable in 2017. And in that case, we were able to capture yield response due to the fertilizer application. In 17, there was an increase in total yield with increase of any fertilizer rate. The rate of 280 pounds per acre yielded more than 170. However, 225 yields similar to 280 and to 170 statistically. Marketable yield was significantly higher for 225 and 280 pounds of nitrogen per acre compared to 170. There was no difference in marketable yields for the rate of 170 across years, 2016 and 17, confirming that even when growing conditions are favorable, as observed in 17, 170 pounds per acre of nitrogen fertilizer was not enough to support the potential yield. These results indicate that the cabbage yield might be limited 170, but not with 225 pounds of nitrogen per acre. Another study was conducted using plastic culture. In this case, for 2 consecutive years, with a higher plant population of 31,363 plants per acre. The rates were 80, 200, 300, 400, 500, 600 pounds of nitrogen per acre. That sounds high, but when we get the equivalent of nitrogen per plant, it ranges from 0.06 to 0.019 pounds of nitrogen per plant. Pre-plant granular fertilizer blend was incorporated in the beds using 80 pounds of nitrogen per acre. Fertigation of calcium nitrate was then used to adjust the rates of each treatment. Fertigation scheduling supplied fertilizer increasing concentrations as the plant grows exponentially. The number of fertigations events were 7, in which fertilizer was distributed at 5%, 5%, 10%, 20%, 25, 25, and 10% as indicated by the arrows. So in this graph, you see the cabbage market yield response increased with the increasing rate of fertilizer. So both years in this case were combined. So different weather conditions allow us to investigate the yield response to any fertilizer and determine the optimal nitrogen application range regardless of weather. Maximum cabbage marketable yield, as indicated by the response of the quadratic plateau, was reached with any nitrogen fertilizer rate of 355 pounds per acre, equivalent to 0.0113 pounds of nitrogen per plant. And no additional increase in yield with any fertilizer rates above 355 were observed. The results from the plastic mulch trials are comparable to the bare ground when the rates are expressed on a plant population basis, indicating that a minimum nitrogen fertilizer of 0.0115 pounds per plant is required, and per plant rate can be adjusted accordingly to the plant population. For example, bare ground cabbage produced with 19,600 plants per acre would require a fertilizer rate of 225, while cabbage on plastic culture with a population of 26,136 plants per acre would require a rate of 300 pounds of nitrogen per acre to achieve maximum yield. So the selection of a realistic any fertilizer rate for cabbage is an important decision that will directly impact the yield, economic return, and potential nitrogen leaching. Any fertilizer rate is not the only factor limiting cabbage yield. Other factors impacting potential yield include planting dates, cultivars, soil type, weather condition, disease and pest management, and adequate irrigation. A commercial cabbage head size ranges between 2 and 4 pounds. Oversized heads above 4 pounds are not desirable and frequently refused by buyers. Cabbage yield is limited to 1 head per plant, so increasing plant population per acre is the only way to increase yield per area. And excessive nitrogen fertilizer applications will not increase yield because there is a limit on the commercial cabbage head size, assuring that a required amount of nitrogen is available for plant uptake when needed is critical for a successful nutrient management plan. IFAS has determined that the cabbage plant will require about 0.0115 pounds per of nitrogen fertilizer per plant to maximize yield. Here's the table 3, presents the equivalent nitrogen fertilizer rate recommendation according to the variations in plant population based on row spacing and in-row plant spacing for bare ground cabbage. As the plant population increases, the nitrogen fertilizer rate increases proportionally. And here, the similar table presents the equivalent nanny fertilizer rate according to the plant population for plastic mulch in cabbage production. Increasing any nitrogen fertilizer rates showed a positive response to marketable yield up to a point, 225 pounds per acre per ground, 335 for high plant population plastic mulch. At any fertilizer rates above this point, marketable yield stops responding to increasing fertilizer, as we see in this picture, in this figure, reducing net returns and may occur in increasing cost due to the increasing cost of fertilizer. So any fertilizer application timing can effectively reduce any fertilizer leaching in cabbage production because of the improved synchronization with crop demand. The optimum application timing of any fertilizer for cabbage should match the nutrient uptake curve that we see in the schematic on these graphs. In practice, 3 or 4 applications should be considered. For bare ground, applications of 20 to 30% of the nitrogen can be incorporated in the row or at the bed at the planting, followed by 2 additional applications at 6 to 8 inches tall plants and at the initial head formation stage. Stop grass, banded or knifed in on the side of the rows with liquid fertilizer. IFAS guidelines for any fertilizer rate for fresh cabbage has been adjusted from 175 to 225 pounds per acre, considering the adjustment by plant population for bare ground and plastic mulch systems. The adjustment will allow cabbage producers to maintain economically viable yields and sustainable operations across production systems common to the Florida vegetable industry, while mitigating water quality impacts associated with over-fertilization, improper timing of application, and high rainfall events. More information about this topic can be found in IDIS HS 1428. I will thank you for your attention.